Thanks for joining me. Oh, Thomas, I'm sorry, that's late. That's past my bedtime. Thanks for joining me. I hope that this conversation will be useful to somebody. This is a presentation similar to something I presented at NI Week about 3 or 4 years ago when they used to do that. And I got a lot of requests for it, so I'm rehashing it. And so really this is my view on using DQMH in TestStand. I know that there's a DQMH consortium out there. I don't know how they feel about my thoughts on this. I've never talked to them. For all I know, they might disagree with me on a lot of this stuff. But I am a TestStand expert. I've been doing this a long time, about 17 years. I'm a certified TestStand architect, certified LabVIEW architect, LabVIEW champion. Yeah, I've been doing this a while. And so really the point of this presentation is just kind of my view on how DQMH should be used in TestStand. I encourage lots of questions on the chat. I will be monitoring that as best that I can while I'm presenting. Probably won't see it while I'm doing the demos. But yeah, feel free to pipe in. Lots of questions, lots of interaction. I can feed off that. So our giants are female. I chose Fabiola. A lot of you guys know Fabiola. She's really the inspiration for this presentation. She's done too many amazing things to list everything, but she's a LabVIEW champion. She wrote an awesome book. If you haven't read it, it's a graphical programming LabVIEW guide. And she is the one who I say invented DQMH. I don't know if she's the one that invented it, but she's certainly the brains behind most of it. And so I've actually taught a DQMH course with her and got to know her really well. So she's an amazing person. Here is the agenda for today. Again, feel free to type any questions. We're going to kind of go over what DQMH is. For those of you that answered on the never used it, well, there's only one person, and the not really on our poll. This will be a good get you up to speed on what DQMH is. We'll talk about the role of TestStand with DQMH and how you should view that role. We'll talk about handling events, and then we'll talk about a little bit about debugging, and then we'll have a couple demos along the way. So we'll follow that agenda. So for those of you that aren't familiar, DQMH, Delacorte queued message handler, are these modules, and you think of them, at least in my mind, I think of them as standalone pieces of code with an API that you can call into, and they have their own memory space, almost like a functional global, but on steroids. They can store a lot of data. They can do a lot of functionality. They're easily reusable, which I think is appealing to a lot of people. They use queued message handlers or messages to communicate. And the other nice thing about them is you can call them at any point from your external callers. So because you can kind of treat them like these standalone modules that are always kind of running in the background in memory and in LabVIEW, you can kind of call them wherever you want, almost asynchronously without passing around handles or wires or objects or anything like that, which I think is another reason that they're appealing to a lot of people. So right here, I have an example of like a thermal chamber controller, what that API might look like. Or actually, sorry, this is like what our code we're going to look at in a minute looks like. This code is calling into two DQMH modules, a thermal chamber controller and a UUT communication layer. And so this is kind of what it looks like if you were to put it into TestStand, which we'll be looking at in a minute. So it's nice because you can share those, call a bunch of different modules from essentially the same code. And they kind of just reside in their own memory space. So let's look inside of a module. For those of you familiar with LabVIEW and with the modules, basically you have these classes. Well, really they're libraries. Sorry, I'm not supposed to say classes because the whole point of DQMH is to not use object-oriented programming. You have these LV libs, LabVIEW libraries, and you have some public, what they call the public API, and you have the main VI, and then you have the tester. And so let's look at some of these in a little more detail. The main VI is basically the brains for the module. It contains all of your code that does all the heavy lifting. It's what the public API interfaces to and sends messages to, and gets messages from. And so that's where you're going to do most of your heavy lifting. And you notice that the main VI is private. It has that little key on. It's not meant to be called externally. You're supposed to call it through the API. You're never supposed to call that main VI. In fact, you can't because it's private. You can't call that externally from an external caller. The public API is basically a bunch of VIs that know how to send messages to the main VI to tell the main VI what to do. And they also receive information from the main VI. And there's different types of events that we're going to look at in a minute. That the events, you want to use different types of events for different reasons. And we'll look at that in a minute. And then there's a whole bunch of private VIs that are just the underlying framework, and any helpers and any like special data types and things like that are in all of these private VIs. And I'm not going to get into those private VI folders in this course, but there's a bunch of stuff that you will probably never touch because the way they've automated DQMH, it's really nice. A lot of the tools that you call out of LabVIEW just do it for you. And then the last, and probably always stressed by Fabiola, the most important part of a module is this tester. This tester, you notice, is not part of the library. It's a standalone VI that is used to basically call each of the API methods. I can't call them methods. Each of the API calls, and really, if your module works in the tester, it will work from anything. And so the nice thing about this framework is it keeps these modules super isolated, and you can do all of your testing from that tester, and you don't have to have this big monolithic application to test little pieces of your code, which is really nice. It really just mimics that external caller. So any questions? Not a lot of activity on the chat. I want to make sure that if you guys have anything, I'm answering it. So awesome. Thank you. So there's really 2+ types of modules. I was told I had to put the plus in there. That last comment makes us very attractive. I still, to preface, I still think Actor Framework is better, but I think DQMH has its place. 2+ types of modules. The reason I put the plus in there is because there's 2 main ones that ship with DQMH out of the box. You can go add whatever type of module you want. You can extend DQMH. It has a lot of flexibility in that regard. So you can create your own types of modules if you want. The 2 out of the box ones are the singletons, they call them, or the clonable. A singleton, you only have one instance of that in memory at a time. And that means anybody who's calling it, any of your external callers, whether it's LabVIEW or TestStand, they are all sharing that same application space, that same module. And so the nice thing about this is, let's say you have one temp controller, which we'll see in a minute, and you want all of your threads to be talking to that same temp controller. You want a singleton in that case. Yeah, that's fair, Chris. The clonable can have multiple instances in memory at a time. You can call the public API methods by using a unique ID that you receive when you create the module or the instance of the module. And so this is nice if you have 5 power supplies on your test station. You can talk to, you need different modules because you don't want to have to go create a separate module for each power supply. You want a different instance for each power supply. And so that's why you would use the clonable. To be fair, Chris, and back to your comment about Actor Framework, I guess I should have said I tend to choose Actor Framework a lot more often than I choose DQMH for projects. To me, I just have more use. To me, it's a better framework for my needs, I guess I should say. So you're right. Clonable can be run as a singleton. I think there's a flag that you sent in there to tell it to be a singleton. And so you can force it into that mode as well. But like I said, you can always extend DQMH to many other, you can add different types of modules as well. And if I say anything that is incorrect, I appreciate it if you correct me, because I am still learning this as well. So, all right, let's look at some events. Events are basically the API, like I said earlier. They're ways of getting information to and from the DQMH module, right? It's basically the way for your external app to act on it. There's 4 main types of events. And again, I think you can extend that and add other types of events if you really wanted to, and you got into it. But we're going to look at the 4 main ones in this presentation. There's a request, a broadcast, a request and wait for reply, and a round trip. So the first one is the simplest one. It's a request. The caller, this shows the internal guts, basically, of that request and what's going on. So from the caller, you would call something that looks like this. So in this case, I'm trying to set a set point in my thermal chamber, and I send that value in. I call that VI just like that from my external caller. Inside of that VI, there's a public API that triggers an event. And you don't have to create these events. They all get created for you by the tooling that's around DQMH. And so that set point gets into here. Eventually, it calls this event. This event then triggers a queue in the main VI that then enqueues some sort of, so the main VI is essentially, it looks like a queued message handler, which is where the QMH comes from. And so it queues up that set point event into the lower loop, or the loop that handles everything. And then your main VI message handler loop, it dequeues that and performs the task. And so that task would be the code that you would create inside of this thermal thing. So Martin asks, what's the best way to keep track of instances of clonable module and TestStand? Keeping track of the ID can be a bit cumbersome through subsequences. That's a good question. I still think that you should always pass it to the subsequence, because if you don't pass it to the subsequence, well, I guess you can use station globals. I don't prefer station globals. I don't like station globals. My rule of thumb for TestStand, yeah, thank you. My rule of thumb for TestStand is that any of the cyan or blue sequences should always be parameterized, and they should never call a file global or a station global inside of them. That makes them more reusable. And so in my opinion, you should have some kind of array that you can track those in from your main sequence, and then pass those into subsequences when needed. That's how I would do it. The other option is you can use I don't know if you know of temporaries. They call them temporary globals inside of TestStand. They're like a hidden thing that's inside of the engine that you can inject them into and then grab them when you need them from wherever. It's kind of it's the fringe stuff of TestStand that nobody ever hears about. So yes, you can save it in a TestStand variable, and that's what I would do initially when I created it, and then pass it into the subsequence. Actually, we'll look in the example. I think I do that. So we'll look at that and see how I do that. The next event is the broadcast event. This is when you want to get something from the module. And so basically what you're doing on a broadcast is you have to register for the event. And so you call this VI that will give you the event. And then you set up the event in LabVIEW in your caller. And then you, the main VI calls this broadcast VI at some point when that event occurs. Like, let's say you're waiting for it to get to a certain set point, and then you want it to trigger that event. And then when it gets there, what it will do is it will go into that API and trigger that event so that your caller will then see that. And then you have to handle that in your caller. And you're sitting there like, wait, TestStand can't handle events. Oh, how do you handle this in TestStand? That's a great question, and we will get to that in a minute. But I want to talk about this one real quick before we get to that other one. This is basically request and wait for reply. Basically, the external caller requests information from DQMH, in this case, a set point. You have a public API that triggers the event. The main VI handles that event, and then the main VI also triggers the event. So basically, if you're following along, it's essentially the the last two events, the request and almost the broadcast, except that you don't have to wait for it in your caller. It just gives that data back to you. So then the public API just waits for that notifier and returns the payload. And so this is really the ideal if you can for TestStand. If you can't and you're only stuck with these, we'll talk about that in a minute. And then there's a round trip, which is a request and wait for reply, and the broadcast. I've never really used this one, so I don't know a ton about it. If somebody wants to put in the chat why this is useful or how this is useful, or if I'm missing something, that would be great. But I don't use this one very often, so. Okay. It's useful when debugging with the tester. Awesome. Great. So here's kind of the role of TestStand. When I think about these DQMH modules, I almost think about them like a HAL or an abstraction layer, if you will, where they know how to perform certain functionality, and you want to reuse that functionality in any type of caller possible. And so you're sharing that functionality amongst all of these different applications. Now, let's say you have some big, hairy, crazy GUI, or your tester VI, or any other LabVIEW application. You should treat TestStand just like one of those other, callers, potential callers. What I want to advise against is calling into your tester and calling into your GUI from TestStand. Do not do that. Always call directly into the DQMH module from TestStand. We will see that in a minute, that sometimes you have to put a wrapper around it. And we'll talk about that in a minute, but always treat these like they're just basically like libraries, essentially, that you're going to consume into TestStand. Don't ever consume the tester or the GUI or any other LabVIEW code unless it's a wrapper into TestStand. So hopefully that makes sense. So something kind of like this. So you have TestStand, you want to talk to a thermal chamber and to your UUT. So you create two modules. You have request and wait for reply. You have broadcast. And so you want to talk to these modules like this from TestStand. So with a request, you just call as a normal step. This is pretty easy because you're just sending information to the DQMH module and you don't care about the acknowledgement. You just want to send off a piece of information, say, go do this or go get this or go handle this, and you don't care. And so this is pretty straightforward. You're going to throw down a LabVIEW step. You're going to call it directly. Pretty easy. Now, the request and wait for a reply, it's very similar to the request. You're going to throw down a step. You're going to call it directly. You call it as a normal step. It will thread lock, though, until it is complete, meaning none of the other steps will execute until that get temperature is done executing. Okay. So if you want to use the broadcast, what I generally do is I create a VI to handle the event. So this would be my wrapper essentially for the broadcast. I try to never put TestStand code or TestStand direct, I guess, calls or like the sequence context or anything specifically related to TestStand inside of my DQMH modules. Because once I do that, those DQMH modules no longer become really usable out. Chris, those DQMH modules never really become usable outside of TestStand. And so once you do that, once you put like a sequence context or like these monitor things inside of your DQMH module, you now have to have TestStand accompanying it unless you put all this casing or conditional stuff around it. And so I try to avoid that because then I can take that DQMH module and I can use it in a LabVIEW only application. I can use it in a TestStand application. I can use it for many things, and it maximizes shared code. How do you handle termination monitoring? We will see that, James, in a minute. I'll open up this VI and we'll get into the guts of it. But yeah, that's basically, I think this VI is starting that, or at least that one's starting the termination monitoring. This one's closing it, and then in my timeout loop, I check to see if it's timed out. So, but we'll look at that VI in a minute. So, actually, here we go. We need an exit strategy, which is what James was asking about. So basically, you pass in the sequence context. You have the start monitor thread. Basically, this thing is just watching the application manager underneath the hood or the engine, and it sees if there's any termination that occurs. When a termination occurs, this outputs a true. That true will prematurely close this loop. That will then kill the VI and close and clean up the termination monitor status. And so I just do that in a timeout. No, okay, let me clarify. I said not to put TestStand code in my DQMH module. This VI right here that I'm showing is a wrapper that I wrap around the DQMH module. If you go back to here, this is where you would have that broadcast event right here. In this case, you're probably not going to have anything because you're just waiting for the event to happen, and then you're probably going to pass the information back into TestStand. But this is a wrapper VI. Don't put this code inside of the module itself. Keep this VI outside of that module, essentially. I mean, I guess you could put it in the module, but only call it, yes, in the API, which is part of the module. Yeah. All right. The thing with that one is it needs to be synchronous. So what you would do inside of TestStand is you would probably call another thread, and you would have the nice thing about the broadcast is you can call another thread. That thread can watch that broadcast. You can do a bunch of other stuff asynchronously. You can wait for that thread to complete and then continue on when everything's wrapped up. And we'll see that in the example in a minute. So. It does Fail, when you say fail gracefully, it will stop. If this, oh, no, it throws an error. It's annoying. You have to like handle the error. So, all right. So here's another consideration. So I create DQMH essentially libraries. Actually, let me go to this slide first, and then the other slide will make sense. So basically, I create like a sequence that can talk to the temp chamber controller, and then I put all of my, essentially this is like a tester, but as a sequence for each one of the API calls. And then my UUT library is the same kind of thing, right? It's like, it's a standalone sequence. It's calling into that a DQMH module, and it acts like a tester. The nice thing about doing this is you can then go and add to your tools menu a calls directly into those sequence files. And then you can call them from the tools menu directly. And this is another reason why, you know, you don't want to use any TestStand references or any, I mean, I guess this isn't a good reason, but again, I just want to reiterate the point. I try not to do TestStand specific things in the DQMH module. So let's kind of look at it. I think I have a demo, or we can go look at this. So what that looks like is I can go to my tools menu at any point. I can say, hey, I want to play around with the UUT, right? I can pop up the tester. I can say, okay, let's run a new instance. Maybe, there we go. So I got like 3 of these going, right? I can choose, I can show the panels. It will show it for all of them, I think. I can then go, you know, where's a power on? It'll power them all on, power them all off, run a self-test, you know, all that stuff. I can shut them down, hide all the front panels, stop all the module instances, kill it. This is nice because I can just do this right from the tools menu. I can do the same thing with the thermal chamber. Call the tester. You can start the module. I can show the front panel. And we'll look at like what a profile is in a second. But the way I've set up a profile is basically it's a ramp and soak. And so let's say that I want to ramp to 50 at a ramp rate of 10. I want to soak for 3 seconds. And once it hits that 3 seconds, then it should tell me that it's completed. And so it doesn't get that event, that completed event doesn't occur until that 3 second time has elapsed, right? So if I want to go to like -50 at a ramp rate of 40 degrees per second, I'm going to start that profile. It'll ramp down, and it will wait 3 seconds, and then that completed should pop on. So I can always get the current temperature whenever I want. Hide the module, stop the module, close that out. All right. Before I run this though, I want to, I've been playing around with it, so I want to unload all modules before I run this next part. Any questions on that in the chat? No. Okay. So the scenario is you have a thermal chamber, you have a UUT, you need to do a bunch of testing at the different extremes. Let's say you want to run it for ambient for a little bit and then run a test. You want to ramp and soak and then run a test, ramp and soak, run a test, ramp and soak, run a test, ramp and soak, run a test, and so on until you get through a bunch of cycles. And so I call a profile, essentially each one of these different colors is a profile. So a ramp, a soak, and a test would all be considered a profile in my example that we're going to look at. And so this thermal architecture in TestStand. So what's basically happening, we'll hop over to the code in a minute, but basically you're going to, this is just setting a flag back to what it should be. I'm going to start that temp chamber by calling into the start. So it might be better just to go through here. I'm going to call this the start temp chamber, which basically calls into this TCC and runs the start and sync module right here. And then I'm going to go get the profiles, which are actually coming from a different sequence, which is defined by the pre-UUT. So there's pre-UUT dialog is going to pop up. That's going to ask me which module I want to test. And that module has information in it. And part of that information is going to be this profile, which will tell me the ramp and soak sequence for that specific UUT. Calling the test VI well. That is correct, and we'll see that in a minute, David. Good point. And so each UUT can define its own profile by allowing me to call into it and get its profile. So that's not going to be part of the test module. That's not part of a DQMH module. That's just part of the sequence. In fact, I should. Where's this saved? Where is this saved? Come on, grab it. Let me show you what one of those files looks like so you can see that. That folder right there. So I call them gadget. They're actually test abstraction layers. But so if I open one of these, it's basically you have your test, which is calling into that, again, that UUT library, which is just wrapping the DQMH stuff. And then it's configuring the DUT, doing a self-test, stopping the DUT. And then I have this get profile sequence, which basically just returns this local variable, which I can then come and edit and change the profile for that. So in this case, it's going to go to ambient. It's going to go to 22. It's going to run for at a ramp rate of 5 seconds. It's going to soak for 2. Then the next cycle or next profile, it's going to go to -50. Then the next one, all I have to do is come in here and add elements into this array, and that will drive this looping right here. It will drive the ramp and soak for my thermal chamber. This step right here is calling this monitor temperature thing asynchronously, which is basically just a call into the get temperature and just sitting there reading the temperature until it gets to a certain point. If I go into here, this is calling, yep. That's just calling right into the module. So, and then I loop through that profile. I wait for the profile to complete, which this is the wrapper VI that I created. And so if we pop that open, maybe. It's always when you do a demo that your machine runs slow, right? So this is that wrapper VI that I was going through in the slides. Basically, inside of here, I have 2 things that can make this, well, 3 things really, that can make this exit early. I guess there's really 2 things. There's the termination monitor, and then there's the timeout. And then once I get that completed status back from the chamber, all I want to do is kill the loop or kill this VI from running. So So once that profile is completed, then it will continue on to the next ramp and soak essentially. And the reason this says changes is because I'm going to call back into that gadget file dynamically into this test sequence right here. So that way you can add different gadgets to this architecture really easily by just adding new TAL files. TAL stands for test abstraction layer if you're not familiar with that. So then I set my stop monitor flag, which goes and stops this. The only reason I have this running is to capture the temperature off of the thermal chamber and display it. And you'll see when I do the debug tools in a second why that's important. Parameter. Oh, you're talking about this right here. Yeah, so I basically pass that stop monitor flag into this by reference. And so this is sitting there watching that. When this sets that back to true, it will kill that thread essentially. So how do you suggest that we monitor the error broadcast event from a DQMH module? Is that something that's ongoing? Because I think what you could do in your pre-U2 or even your what do they call that? The callback, it's eluding me. The process setup. The process setup, you could kick off that that broadcast thing, create a wrapper VI, and just kick that off asynchronously, and just have a monitor. And then when it gets an error, it will throw an error. And then at the end of your in the process cleanup, you can just go kill that VI somehow via flag or some other thing, I guess. I don't know if that answers your question. That's one way. I'm just thinking off the top of my head. So this is just for safety. I mean, this flag should stop it, but really I want to wait for it to really stop. And so this just waits for that monitor temperature to kill. And then the thermal profile, this is a VI that I wrote to grab some HTML encoding that I can spit into the report so that it will show up as a picture on my report of the actual thermal profile. That's a good idea. Calling sequence using error. Yeah, that's an option too. Probably better actually. And then I just shut down the temp chamber. I'm assuming in this architecture that each one of these gadgets are handling their own DQMH module underneath the hood for the UUT communication, and that this client file is only dealing with the temp chamber. The reason I did that is so that this can be a lot more flexible, and this can handle a lot more UUTs. Because once you start closing down UUTs inside of here, then it gets really messy, and now you're just very specific for a single UUT. So questions, other questions, comments? So this kind of shows all the layers of what's getting called here. Yeah, lots of stuff going on. All right, let's watch it in action. So I'm going to, we'll just execute it so we can see what it works like. Good job preloading modules. That's one thing I noticed when you use DQMH, it does load a lot of stuff into TestStand because you got to bring the whole LV-lib in. So we have 3, it looks like. I'm just going to do gadget 2, throw in some information there. Continue. So this is basically looping. And one of you made the comment that I can go into here and I can just pull my tester up and I can watch this. I guess I could have just called this directly. So you can see that profile running. So it's doing different tests on the UUT after it gets to that soak period. Oh, crap. Okay, maybe you can't pull that up. That's not good. Let's kill it. Looks like I got a bug. Let me, oh, I can't do that. It's still running, isn't it? Where is it? All right, stop. Okay. Let's do this. Let's run it without interfering with it for a minute. I want to see if I know it will execute without that. All right. I'll do this again. The other thing you could do, I guess, is you could just say, show the temp chamber thing inside of here. So it's always showing. So you can watch that as well. I can show you how that's done when this is done. Actually, we're running close to time, so I don't know if I'll have time, but let's see. Because it's nice to be able to watch, I guess, that thermal cycle run, because that's a lot of times you have those techs down in the lab and they got hundreds of thermal chambers they're watching. They walk around. Oh my gosh. Looks like I have a bug in there somewhere. This worked right before I presented. Not going to show, is it? Oh. That's crazy. I don't know what's going on. Let me kick TestStand real quick. I wonder if there's something in memory that's causing that. Uh-oh. Yeah. That wasn't good. Unreleased stuff. Got 2 instances going. All right, where are you? TCC client. Let's try with a clean slate. If this doesn't work, I apologize. And this is where you want to see what's going on. Blah, blah, blah. Yeah, to answer your question, David. I mean, basically, in probably right here somewhere, I would just say show temp chamber, and then it would always be up in front running, and then you could hide it through that same API. Sometimes I want, oh, I know what's going on. You have to be, to use these tools, you have to be in the runtime engine, LabVIEW runtime engine. And so you have to deploy it so that they can share the same application space. Otherwise, you get those weird issues. Well, that's my theory. Yeah, and there's your profile, and then it shows all of the tests. And I pull those names from the profiles, so you can see which cycle they're on and different things for the report. So. Real quick, here's what I would do. I would show So we'll do the show one, show panel, and then we'll hide in the cleanup. Please share your demo code somewhere. Yeah, I can share the demo code. I don't know where I thought it was out there already. I'll grab it, but I think it's confined to 2017 because I'm using a PPL that I don't have the source code for. I don't know where I lost it. So, so now we should see that showing, right, as it runs. Oh, yeah, I'll talk about that in a minute, James. I use PPLs for everything when it comes down to it. So there you go. It's running. To James's point, what you can do is those DQMH sequence files, you can create a PPL for each one of them, which is basically just your DQMH module. Yeah, great. Something's not cleaning up properly with the stupid temp chamber. I got to figure that out. But you get the point. I think that something with the stop temp chamber is not working properly. And so the next time I execute it, it's having issues. Anyways, I can figure that out. But back to this point, your pack project library, usually when I develop in TestStand, I develop against PPLs. So I have a HAL that's OO, that's not DQMH, that I call a lot from TestStand. And each one of those HAL items is essentially their own PPLs. And so I use those. With DQMH, I'll create that DQMH library, that sequence library, and then I'll set that right next to a packed project library that's basically my DQMH module just packaged up into a PPL. And it's a lot easier to deploy because you can do all this from LabVIEW and you don't have to use the TestStand deployment utility, which I'm not afraid of the TestStand deployment utility. I'm very used to it. It's just a lot easier to deploy stuff from LabVIEW, especially when you're dealing with LabVIEW code. So basically a system, correct, James. I basically will build PPLs and treat them like DLLs. And then I'll, from TestStand, just call into those. And then I'll take all those I'll actually create NI packages. So for NIPM out of those PPLs and accompanying sequence files. And so then I'll just deploy the packages. So yes, I do not deploy a bunch of code. In fact, my projects, my team's projects are generally about 100 packages. No, not that many, but a lot of packages. But each package is like 1 or 2 PPLs and a couple sequence files, or maybe just a single sequence file, or in some cases just single or multiple PPLs. So basically, our system is built. Our systems are built of a bunch of packed project bunch of packages, NI packages. So we'll just create a feed for a system, and we'll throw whatever packages are needed on there. This way we can maximize code reuse, because now I can just take that sequence library, I can take that DQMH module, and I can put that in a package, and anyone can then consume that package into their feed. And so basically you maximize your code reuse by doing that. And you're not rebuilding that pack project library 1,000 times, which saves on deployment time. So any other questions, thoughts? Okay. I don't really have a conclusion slide, but I guess the big takeaways from this are The big one being the DQMH sequence libraries, and then coding against the Pack project libraries, and then the how to handle the broadcast. Those seem to be two of the things that people struggle with a lot with DQMH and TestStand. It just makes things a lot easier when you kind of modularize it that way. And then when you also keep that TestStand code out of your DQMH module, that makes them cleaner. How do you debug your sequence? You mean just with the TestStand tools? Are you talking about going into the code? I mean here. Oh, so you can turn on, so both great questions. I think you're asking the same thing. Well, I guess James is just clarifying there. In my opinion, and maybe I'm wrong about this, but I haven't had issues with it so far. When you create a PPL, especially a DQMH module, that tester VI is how you test your code. When that is tested and that works, I assume that the PPL is then good. I mean, that's probably a bad assumption. And we have had cases where we've had to debug little things, here and there. But once that PPL standalone is good, then we generally don't have to do a lot of debugging from TestStand. And so we do all of the testing really from LabVIEW, from that tester VI, or from a separate VI. And we test it that way. And then we build the PPL. We assume the PPL is good because it's built using good code. See what have been passed into a step. Well, you can pause TestStand and just look at the variables and see what's going in and out of those PPLs. That's all built into TestStand. But you can build PPLs with debug turned on, so you can step into them. I don't like doing that, especially on a deployed machine, just because you have the deployed utility. So, yeah. Cool. Agreed. Sometimes round trips. Yeah. Okay. I get it. Yeah, that's fair. Yeah. I don't know why this isn't working. I've never had this issue with the thread thing. Usually I can just pop these open fine. And in all honesty, I haven't opened this example in a long time until late last week. So I'm sure that something's changed, and I don't know what I didn't have time to debug that. So, but yes, if you do it correctly, you can pop this open and you can watch what's going on inside of the DQMH module. So. All right, we're out of time. I think we're only supposed to go to 45 after, right? Any other questions? I'll stick around for a little bit if you guys have some more comments, questions, anything like that. Thank you.